Okay, chapter 1.4, the other types of equations. Okay, there are so many types of equations. First of all, let's check a polynomial equation. Okay, this is a polynomial equation because the degree is 3, 2, 1, and so on, right? Okay, so when we solve this one, we can factor this first. So in order to factor this one, there are 4 terms that we may think the factor by grouping. Okay, factor by grouping. Okay, this means we're gonna make a group of 2 terms. So one group and another group. So from the first 2 groups, the first 2 terms, we can factor this one. So the common factor is x squared. So factor out x squared. Then x cubed becomes x, and then x squared went out, so 3 left. Okay, for the second group, the common factor is -4, right? -4, so factor out -4. Then the first term will become x, and the second term is, since negative is went out, this one becomes positive 3. Okay, as you see this, we have a binomial factor, right? Binomial factor, and these 2 are the same. So these 2 factors are the same. So we can factor out x plus 3. So factor out x plus 3 and then put parentheses. Since x plus 3 factored, x squared left over, and -4 is the factor left over. Okay. So we factored the 4, this polynomial expression, and then we can also factor this binomial, right? Because this is a difference of squares. So remember difference of squares, x squared minus b squared can be factored as a plus b times a minus b. All right. So we can rewrite this binomial factor as the product of, actually this is equal to 4 is 2 squared, right? 2 squared. So x plus 3 times x plus 2, x minus 2 equals 0. All right. Then, since we want to find the solution, and the expression is already factored, and the product of these 3 factors is equal to 0, so that we're gonna make each factor equal to 0. So from the first factor, we can find the value of x is -3. From the second factor, the value of x equals -2. And from the third factor, x is 2. Right, so there are 3 solutions. 3 solutions. X equals -3, -2, or 2. Okay. Okay, next example is a rational equation. Okay, rational equation means it's an equation, but it contains a fraction. And especially the denominator of the fraction contains a variable term. A variable term in the denominator. So since the denominator cannot be equal to 0, so always keep in mind that the denominator cannot be equal to 0. So if we have a x value that makes the denominator 0, then that value will not be the solution anymore, because we know that denominator cannot be equal to 0. All right, so when we solve this equation, okay, the first thing is we have to find the LCD. Okay, LCD. So what is LCD? Okay, LCD is the LCM of the denominators. LCM is the least common multiple. So we want to find the least common multiple of the denominators. So this is x plus 4, right? X plus 4, x plus 4. So there's only one factor, x plus 4. So we're going to multiply the whole equation by x plus 4. Okay, multiply this by x plus 4. So that means, okay, when we multiply this by x plus 4, so multiply the right hand side by x plus 4 as well. That means we're going to multiply each term inside the parenthesis by x plus 4, right? So let me rewrite it. So that is 2x plus 1 over x plus 4. So this will be multiplied by x plus 4. And this 3 will be multiplied by x plus 4. And negative 2 over x plus 4. This will be multiplied by x plus 4. Okay, I'm going to put parentheses in the denominator. Okay, the reason I wrote this is, look at this. Okay, when we multiply the left-hand side of the equation by x plus 4 and the right side by x plus 4, this means we multiply each term in the equation, by x plus 4. So this is the first term, right? First term by x plus 4. So 3 by x plus 4. So we are multiplying each term by x plus 4, so that we can skip, this step. So anyway, so when we multiply the x plus 4, we can cancel out the denominator because they are same binomial factors. So just get rid of it so that we have x plus 1. And then from here, we're going to multiply these 3. And then from the right hand side, you can cancel this out. So we have negative 2. So there's no more denominators, right? No more denominators. So from here, we can just find the x using just regular method. So this is 2x plus 1. And then distribute. So the first one will be 3x. So 4 times 3 is 12, and then minus 2. So before we collecting or sending away constants, we will combine the like terms first. So simplify each side. Then this will be 5x. 1 plus 12 is 13, right? Okay, then next, move plus 13 to the other side. So minus 13 each side. Then 5x equals negative 15. And then what will be the next? Divide each side by 5. So x equals negative 3. Now, we have a negative 3 as a solution. Do you remember this part? The denominator cannot be equal to 0. The denominator cannot be equal to 0, right? Cannot be equal to 0. So check. So this means x plus 4 cannot be equal to 0. So x cannot be equal to negative 4. So as long as the value is not negative 4, then that will be the solution. So negative 3 is not negative 4. So this one is not negative 4. So this is the solution. Can you see it? All right, then let's try out next one. The next example is also an equation, rational equation. As you see this, the denominator is x minus 2, right? X minus 2. So x minus 2 is the LCD in this case. I'm going to multiply the equation by LCD. Okay, multiply the equation by LCD means multiply each term, right? Each term in the equation. Each term in the equation. All right. And then also note that the denominator cannot be equal to 0. So x minus 2 is the denominator, and this x minus 2 cannot be equal to 0, which means x cannot be equal to 2, right? So if x equals 2, then the denominator is 0, then that is undefined. So whenever we get the solution x, if the solution is 2, then 2 is no longer a solution. All right, so let's do it. So let's multiply the equation by LCD, which is x minus 2, which means I'm going to multiply each term by x minus 2, and the second term by x minus 2. So let me write it in the numerator part. So I'm going to multiply this one, right? This by x minus 2. Write it in the numerator. Okay, then do what? Do the distribution, right? Multiply this and then this. So that is 3x squared minus 6x. And then for this one, we can just cancel this out, right? X minus 2. This whole x minus 2 cancel out. So we have only 4 left. And this one cancel out x minus 2. So negative 4x plus 12. All right, so we have an equation. And then since this is quadratic, let's move all the terms from the right to the left. And then factor the left-hand side. Okay, so 3x squared minus 6x. So move this one to the left. There will be positive plus 4x, right? And then we have a plus 4 equals, so not equals yet. Okay, not to be confused, let me write the left-hand side first. So plus 4, right? Then move 4x, minus 4x to the left, so plus 4x. Move 12 to the left, so minus 12 equals 0. Okay, and then simplify the left-hand side of the equation. Then combine these like terms, that is negative 2x, and add the constants, so that is negative 8 equals 0. All right, so this trinomial, from this trinomial, let's factor this one. Okay, so that is, the first term is 3x times 3x, and then 8 is 4 times 2, 2 times 4, maybe 2 times 4. Then put the negative sign so that the center, the sum will be the negative. So let me put the negative sign here. Then do the cross multiply. Then this one will be negative 6x. This product is 4x, right? Then the sum is negative 2x. So this term is same as the term in the middle. So we found the match, the pairs. So this trinomial is the product. It's the product of the first expression in the first line and the second line. Okay, so x minus 2 times 3x plus 4 equals 0. So from this equation, already the left-hand side is already a product, right? Product. So set each factor equal to 0 so that we can find x. So x equals 2. And from the second binomial factor, 3x plus 4 equals 0. Then 3x equals negative 4, right? So x equals negative 4 over 3. So we have two values. And then let's check whether these two values is violated, restrict values. As you see this, look at this. X cannot be equal to 2, right? So we have a value of x that is 2. So remove this one from the solution. Therefore, the only solution is x equals negative 4 thirds. So this is the only solution. Okay, 2 is removed. Why? Because the denominator cannot be equal to 0. So if x equals 2, then the denominator is 0. 2 minus 2 is 0. It's undefined. So remove this value 2 from the solution set. Okay, let's solve this rational equation. Okay, first, let's find the LCD. Okay, the LCD is x minus 3. Okay, how do you find the LCD? Okay, in order to find the LCD, something like this. We have 2x cubed, let's say y squared z. And another one is, okay, let's say this one is 2 to the fourth power. And then we have a 3, like this. And then there is a number 2 cubed x to the fifth power and z to the fourth power, like this. So we have two numbers. Then from this one, the LCD is the LCM, actually LCM, right? And the LCM is the product of all the factors that is greater. So 3, look at this, 3. Okay, 3 is, there's a factor 3, but 3 is the only one, right? So I will mark this 3, so write down 3 times. Okay, 2 is a factor, but this 2 has 4, right? Exponent is 4. There are 4, four two factors, right? 2 factors, there are 4 of them. So we will select 2 to the fourth power. And how about y? How about x? In this case, there are 3 of them. In this case, there are 5 of them. So select the largest exponent. And then z, y. Okay, y, this one is the only one. So select y squared. And then z. This is Z, so Z is, there's only one Z, there are four Z's, so select this guy. All right, so this is the LCD. Same thing. We have x minus 1, x minus 3, x minus 3, right? So we select one of this, and then there is another factor, x plus 4. So we will make a product of these two, x minus 3 and x plus 4. So this is the LCD. So we're going to multiply this LCD, each term in the equation by this LCD. So multiply, I'm going to write it x minus 3 times x plus 4 in the numerator side. And even this one, the second term is x minus 3 times x plus 4. Okay, then I'm going to let me put parentheses around the numerator and the denominator. And even this one, x minus 1 times x minus 3 times x plus 4. Okay, then from here, we can reduce the denominator. So x minus 3 cancel out, right? So we have x plus 4 times 2x. And for the second term, x plus 4 cancel out. So x minus 3 times x plus 1. And this one, the right-hand side of the equation is x minus 3. So cancel it out. So x minus 1 times x plus 4. All right, so this equation does not contain the denominators anymore. And next step is just use the regular method. So distribute first. So there will be 2x squared plus 8x plus, okay, distribute, use the FOIL method, right? So x squared plus x, and then this one is minus 3x. This will be minus 3 equals, do the FOIL method again. Then x squared plus 4x, multiply these two, then negative x, and then finally the last terms is negative 4. And then simplify each side and then collect all the terms to the left. So let's combine the like terms on the left-hand side first. That will be 3x squared, and the variable terms, the next terms. So 8 plus 1 is 9, 9 minus 3 is 6. Okay, the right-hand side is x squared, and these two will make it negative 3x, the minus 4. All right, move all the terms to the left. Move all the terms to the left. So, okay, minus x squared, then there will be 2x squared, right? Then minus 3x, minus 3x. So there will be plus 3x. And then plus 4, plus 4. So the constant will be plus 1 equals 0. All right, so this is an equivalent equation from the previous equation. So from here, let's factor this trinomial. Okay, then this product is x, 2x, and this one is just x. The sum is 3x, which is same as the second term. So the trinomial is the product of what? The first row and the second row. So x plus 1 times 2x plus 1 equals 0. So set each factor, binomial factor, equal to 0, so that we can find the value of x. Right? So x equals, move 1 to the other side, so negative 1, and divide by 2. And then check. Okay, check whether these values makes the denominator 0. All right, so as you see this, the restrict values comes from the denominator. So set the denominator equal to 0. So that if x equals 3 and negative 4, x is 3 and negative 4, then the fraction is undefined. So the equation is undefined. So in that case, check these answers. So we have a negative 1 and negative 1/2. These are not the restrict values, right? This number does not belong to 3 and negative 4. So yes, these two are the solutions in this case. All right. Therefore, the solutions are x equals negative 1 and negative 1/2. Okay, next example is a radical equation. Okay, radical means a square root or cube root, or fourth root, or so we call it an nth root, right? Nth root of x. So these are called radicals. So when we solve this radical equation, we need to remove the radical symbol. So if you see the left hand side, this is a product, right? Product. So okay, first, if this is addition, addition that includes square root, radical expression, then you need to separate it so that you will have radical term on one side, radical term. So in this case, number one, okay, you don't have to divide this by 2 because already, 2 times square root is a radical expression. So just leave it as it is. And then what we do is square each side so that we can remove the square root. So can you see this one? Okay, for the number 2, let's say you have a square root of x, right? If you square this square root, then it will be just x, right? X. So that the square root symbol is removed. So what we're going to do is we will square each side of the equation. Okay? So I'm going to square, okay, square each side of the equation. All right, then 2 times 2 is 4, right? 4, and the square root is removed. Okay, let me rewrite it if you don't get it. So this means 2 squared, right? And then square root of 3x minus 2 squared equals x plus 1 squared. So 2 squared is 4, and then you are squaring the square root. That means get rid of the square root symbol. Get rid of the square root symbol, so we have only the radicand, inside the expression inside the square roots. So that equals. Okay, let's square x plus 1. That is x squared plus 2x plus 1. Do you remember a formula? Okay, a plus b squared. This is binary. So if you square the binary, then it will be the square of the first term, and then multiply ab by 2. So 2 times ab plus b squared. So that is the formula. If this is a minus b squared, then a squared, the first term squared, and the minus 2 times ab plus the second term squared. Okay. Okay, by the way, the square root of something squared. Let's say you have a square root of a star, and this one is squared. Then the answer will be just take this star outside. Okay, star. So same thing. In this case, you have a square root, right? Square root, and this square root is squared. So what we do, take this star out. So we have 3x minus 2. Make sense? All right. Then let's do the distribution property. So 3 times 4 is 12x minus 8 equals x squared plus 2x plus 1. So why don't we move all the terms from the left to the right? Okay. So this will be x squared, and that is minus 10x, and then plus 8 each side. So it will be plus 9, right? Equals 0. So from this, let's factor it. So x times x is x squared. And then 9 is 1 times 9, and put both negative. So negative 1 times negative 9 is 9, right? Then cross product is negative x. This product is negative 9x. And the sum is negative 10x. So this is same as the term in the middle. So 0 equals x minus 1 times x minus 9. So from here, we can set each factor equal to 0. So x minus 1 equals 0, then that x equals 1. X minus 9 is 0, then x equals 9. So we have two values, x plus 1 and 9. So whenever we found the solution, what do? Always check. This is really important. Okay, check. So check this result, the value of x, in the original equation. So the original equation is this one. 2 square root of 3x minus 2 equals x plus 1. So when we plug in x equals 1, okay, let's plug in x equals 1 and see what happens. So 2 times 3 times 1 minus 2. Is it equal? Well, let's check. So if it's equal, then 1 is the solution. Then 2 times square root of 3 minus 2 is 1. So that is 2, right? 2 times 1. So that is 2. How about this one? This is 2, right? So they are equal. Equal, right? So when x equals 1, the equation is true. So 1 is a solution. How about the next one? If x equals 9, let's see what happens. 2 times square root of 3 times 9 minus 2 equals 9 plus 1. Let's check whether this is true. Then 2 times square root of 27 minus 2 is 25. Okay, 27 minus 2. So 2 times square root of 25, that is 2 times 5, so that is 10, right? And then 9 plus 1 is also 10. So they are equal. So since both values 1 and 9 satisfies the equation, the original equation, we can say that the solutions. So the solutions are what? Solutions are 1 and 9. Okay, next example is there are two radical expressions. Two radicals. So in that case, we will separate the radicals. So one is on the left and the other one is on the right side of the equation. Because so let's move the second radical to the right. Now the reason we separate is we want to remove one radical first by squaring each side. Okay, so if we square this expression, then what happens? We can remove one square root, right? Okay, so that is square root. So let's square each side. Okay, so square the left hand side and square the right hand side. Then the left hand side will be only x plus 1. Remember, if you square the square root, then only the inside the square root will be the result. Okay, the right hand side is, okay, square the first term plus 2 times the first term and the second term, right? Plus square the second term. Remember the formula? All right. Then x plus 1 equals 1 plus 2 times square root of 2x minus 5. Then plus, okay, the square of the square root is what? 2x minus 5, right? 2x minus 5. Then simplify the right hand side. Let's simplify the right hand side. Okay, let me write one more. Okay, combine the like terms. So 1 and negative 5, that is negative 4, plus 2 square root of 2x minus 5 plus 2x. All right, then we have a 1 square root left. So there were 2 square roots, two radicals. So we have only 1 radical left. So what we're going to do is leave square root term alone and then move other terms to the left. Okay, so minus 2x each side. Then this will make negative x, and then plus 4 each side. So this will be plus 5. So we have only 2 times square root of 2x minus 5. Can you see it? So now we will square the equation again so that we can remove the square root symbol. So negative x plus 5. We're going to square this one, also square the right hand side. All right. Then use the formula in a plus 1 squared formula. So first term squared. So negative x squared plus 2 times the first term times the second term plus The second term squared. And the right hand side is 2 squared is 4, right? 2 squared times square root of 2x minus 5 squared. Okay. And then next. So from here, alright, so okay, the first one will be x squared minus 10x plus 25 equals 4 times, okay, this is square, so take the inside expression out. Then keep doing it. So as you see this one, there's no square root anymore, right? There's no square root. So now others are the same. What we do is just use the regular method to simplify and then to solve the equation. So minus 20. Okay, let's move the terms from the right to the left. So minus 8x. So minus 8x, then x squared minus 18x. Okay, plus 20 each side. Then there will be 45 equals 0, right? All right, then this the first term is x times x always, and 45 is, you see 3 times 15, 3 times 15, right? And they're both negative, so that the sum will be negative 18. So that is negative 3x, and this product is negative 15x. The sum is negative 18x. Bingo. So this trinomial is the product of x minus 3 and x minus 15. So set each factor equal to 0. Then x minus 3 is 0. So from here, x is what? 3, right? And from the second binomial factor, x minus 15 is 0. So x equals 15. So we have two values, x equals 3 and x is 15. What do? We do checking, right? Checking. Check. So when x equals 3, let's check whether this is true. Okay, the equation is square root of, okay, the equation is square root of x plus 1 minus square root of 2x minus 5 equals 1, right? So let's check. So plug in 3 for x. So square root of 3 plus 1 minus square root of 2 times 3 minus 5 equals 1. Let's check whether this is true. Okay, then this is square root of 4 minus square root of 6 minus 1, right? Then this is 2 minus square root of 5. Okay, I think that is, did I write correctly? X plus 1 2x minus 5 equals 1. So plug in 3, then 6 minus 1, right? Sorry, this is 5. So 6 minus 5. So that is square root of 1. So 2 minus 1 is 1. So the value from the left side is 1. How about the right hand side? This is 1, right? They are equal. So yes, x minus this number, x plus 3 is a solution. Okay, then let's try the other number, the other value, x equals 15. So when x equals 15, let's check. Okay, so let's check this part. Square root of 15. So 3 plus 15 minus square root of 2 times 15 minus 5. Is it equal to 1? Well, let's check. I'm sorry. Okay, not this one. This is x plus 1, right? X plus 1. So 15 plus 1. So this part is 16 minus square root of 30 minus 5 is 25. So let's check whether this is equal to 1. Then 4 minus 5. 4 minus 5 is negative 1, right? Negative 1 is not equal to negative 1 is not equal to 1, right? Not equal to 1. So 15, the value 15 is not a solution. Not a solution. Therefore, the solution is, there's only one solution. In this case, the solution is 3, right? 3. So 15 is no longer a solution because it does not make the equation true. All right, this time there's rational exponent equations. This is a little bit confused. So let me explain a formula. Okay, here's the nth root of x to the nth power. You know, the powers are the same. Okay, before we do this, okay, okay, this one will give you two different solutions. One is just absolute value of x. Okay, absolute value of x, and the other one is just x, depending on the value of n. Okay, n is called the index, right? Index, and the n is it can be also an exponent. So index and the exponents are the same, but if n is even, n is an even number, n is an even number, then we make x positive. If n is odd number, then just take x out. Okay, you don't get this one, right? But let's do an example. So how about square root? The square root of 3 squared. 3 squared. Isn't it 3, right? That is 3, right? That is 3. Because square root means the index is 2. Okay, index is 2. That's the square root. So since the index is 2 and 2, you can take this x out, this 3 out, but make it positive. How about this? You know, 2 is an even number, right? The index 2 is an even number. How about this? Square root of, this is square root, so we usually do not write this 2, but I just want to help you in understanding this square root. How about negative 3 squared? Is it negative 3 or positive 3? The result is positive 3, because once you square the negative 3, what happens? Square the negative 3 becomes 9, right? 9. Negative 3 times negative 3 is 9. Negative 3 times negative 3 is 9, right? Then you can rewrite it. 9 is 3 squared, so the answer will be 3, right? 3. Can you see it? So if inside the square root of something squared, then you can take this one out, but make it positive. So we put the absolute value symbol to make it positive, right? So if the index is what? Even, the even number. Make sense? Okay, here's another example. What if this is a cubic function, cube root of, let's say, 8. 8 is 2 cube, right? 8 is 2 cube. Then this one is equal to just 2. You can take this 2 out. So if the index is odd, then this one can be a negative number, like a negative 8. Negative 8 is what? Negative 2 cubed, right? Negative 2 cubed. So if the index is odd number, then you can have a negative number in the radical symbol. Then the answer will be negative 2. Just take the base out. Just take base out. You don't have to make it positive. Okay? Can you see it? So example. There are two types of example. If the index is what? If the index is odd, then just take the base out. Okay? You don't have to make it positive. So here, if the index is odd, then take this base out. If the index is even, then take the base out, but make it positive. Put the absolute value symbol. Okay, make sense? Okay, here's another property. Okay, here's nth root. Nth root of x to the mth power. Then you can convert this one into an exponential form. There will be, okay, this n will move to the denominator of this exponent. the denominator of the exponent. So it will be m over n. Can you see it? So radical expression can be written as an exponential form, like this. Okay, don't forget this. So if you have something like this, or vice versa, if you have x to the power is 2/3, okay, then this one can be, this denominator can go to the index cube root of x squared, something like this. Okay, so all right. Okay, and then there's another important property. Okay, this is, okay, let's say x squared equals 3. Then always x is plus or minus, take a square root, plus or minus square root on the right hand side, always. So if this is, so if the exponent is 2, right, even, this is even, right, even, then always make plus or minus. There are positive numbers and negative number, okay, always. Okay, keep this in mind. So, the exponent, x to the, let's say 2/3. Okay, 2/3 is 4. Let's say this is 2/3 is 4. 2/3 is, let's say 1. Okay, 1. Then in this case, we can make one cube each side, right? Cube each side. Then this will be x squared equals 1, right? So that x equals plus or minus 1. Can you see it? Another example. So whenever the exponent, the numerator of the exponent is even number, then always make sure the answer is plus or minus. Okay, plus or minus. All right, now let's solve this rational exponent equation. So let's leave this term alone and then move 47 to the other side. Okay, so that is plus 47. So this one is equal to 162, right? 162. And divide each side by 2. Then x to the 4 over 5, fifth power is 81. Okay, now the question is from here. Okay, is it okay with, okay, the numerator is 4, right? So is it okay we take fifth root and the fifth power each side? Okay, fifth power each side. Fifth power each side. Then this 5 cancel out. We have only x to the fourth power. And 81, because 81 is, what is 81? Okay, 81 is, it's 9 times 9, right? 81 is 9 times 9. And then 9 is 3 times 3, and 9 is 3 times 3. So actually 81 is 3 to the fourth power. So can we write it something like this? 3 to the fourth power raised to the fifth power. So x to the fourth power is 3 to the 20th power, right? It's a large number. Okay, but don't worry. If the exponent is 4, then what do we do? X is plus or minus, right? Plus or minus. And since the exponent is 4, we take fourth root. Okay, fourth root of 3 to the 20th power. Make sense? Okay, just like this one. Just like this. If this is x squared, then what do we do? Take plus or minus square root on the right hand side. So that will be x equals plus or minus 1. Remember this one? Plus or minus, take square roots of the right hand side. Okay. So same thing. Since this is 4, even number, so that we put plus or minus, positive or negative, fourth root of this. Then using this information, converting radical to exponential, we will move this 4. Okay, move this index to the denominator of the exponent, right? So this is same as plus or minus 3 to the 20 over fourth power. So x equals plus or minus 3. Okay, 20 over 4 is 5, right? Then x equals plus or minus 3 to the fifth power is 3 to the fourth power is 81, right? 81 times 3 is, that is 81 times 3, right? 81 times 3. 253. So these two are the solutions. Make sense? Okay, this is a little bit confused, so keep practice. Okay, then let's do our next example. All right, so let's move 4 to the other side. So 5 times x to the 3 over 4th power equals minus 4 each side, right? So 40. And then divide each side by 5. So 40 divided by 5 equals 8. All right, now we can raise each side. Raise each side by the denominator 5. Okay, each side by to the fifth power. So that the left hand side is x cubed equals 8 to the fifth power, right? Now, the exponent is 3. This is odd, right? This is odd. Odd. So you don't have to put plus or minus cube root, right? You can do only cube root. Take a cube root on the right hand side. Make sense? So if this is an odd, right? This is okay on the left hand side. This one is what? Even, right? Even. This is even, right? So take plus or minus square root. So this is odd. So there's no plus or minus. Just take. This is the fourth power, fourth root of. This one is a cube root. Okay, no plus or minus. This one has a plus or minus. Can you see the difference? Okay, plus or minus. All right. So x equals this 8 to the fifth power. So why don't I move this to the denominator? Okay, move this one to the denominator of the exponent. So it will be 8 to the 5 over, is it 5 over 3? I think I wrote out wrong information. This is 4, right? Sorry about this one. This is 4. So let me change this one into 4. All right, so I changed the denominator 5 to 4. All right, then from this one, we can move this index to the denominator of the exponent, right? So it will be 8 to the 4 over 3 power, third power. All right, then the next is simple. Okay, what is 8? 8 is 2 cubed, isn't it? That is 2 cubed. So raise this one to the 4 over third power. All right, then x equals, we can multiply the exponents 3 times 4 over 3, right? Then x equals 2 and 3 cancel out is 4. So finally x equals 2 to the fourth power is 16. Wow, long way, huh? Long way. All right, so hope you understand this. So in this case, when you have x to the nth power, then you can take plus or minus nth root on the right hand side. So if the index is even, then you can put plus or minus. If the index is odd, then don't put plus or minus, just square root. Take the radical, okay? All right, then let's try the next example. The next example is are the equations in quadratic form. Okay, quadratic form means, okay, here is variable a coefficient, and then x to the, let's say the exponent is 2n. Okay, 2n plus b times x to the n plus c equals 0. Okay, look at this. The second term, the smaller degree term is n, right? N the larger degree is 2n. So as long as this one, as long as 2n is, okay, the first one is twice. This is the twice the exponent of this term, okay, exponent of this term. Then we can let what? We can let x to the nth power as some kind of u, okay, u. Then what? Then u squared will be, u squared means what? X to the nth power squared, so that is x to 2n, right? So you can set x to the 2n as u squared. So we can rewrite it. So this will be a times u squared, right? U squared plus b times u plus c equals 0. So now we have a quadratic form, right? Quadratic equation form. Can you see it? So whenever the exponent, the degree, the largest degree is twice the second largest degree, then we can set the second term, this one as what? U. Okay, u. Set it as u. Make sense? All right, then we can. So here is okay, let's check an example. So if we have x to the 6th power plus x cubed minus 12 equals 0, then what? We let, so 6 is twice this 3, right? So 3 times 2 is 6. So we can let x cubed as what? U, right? U. So why don't we write u first? So set u equals x cubed. Then u squared is what? X to the 6th power. So we can rewrite this one as u squared plus u minus 12 equals 0, and then solve for u. How about this? Let's say we have a 2 x to the 2/3 power plus 7 times x to the 1/3 power minus 4 is equal to 0. Okay, for this equation, just an example, right? Example. So let's check. So multiply 1/3 by 2. Then this is 2/3, right? Then this 2/3 is same as this one. So we can let, so in that case we can let x to the 1/3 power, so u equals 1/3 power, then u squared will be x to the 2/3 power. Make sense? So we can rewrite this as 2 times u squared plus 7u minus 4 is equal to 0. Okay, look. So whenever you multiply this power by 2, then that is equal to the first degree, this part. Then you can set this as u, then this will be u squared. All right? Okay, don't forget this. All right, let's try next example. Okay, we want to solve this 4th power equation. So we can convert this one into a quadratic form because, okay, 2, right? 2. So 2 times 2. 2 times 2 equals 4, right? So this 4 is this guy, right? So 2 times 2 is 4. So we can let u be x squared. And then u squared will be x to the 4th power, right? So we can convert this equation into a quadratic form. So that is x times u squared minus 25u plus 36 equals 0. So since this equation is quadratic, we can solve for u, right? Solve for u. Okay, that is, okay, u times 4u. Let's try this one. U times 4u. And 36 is 9 times u, 9 times 4, or 4 times 9. 4 times 9 is 36, right? So put both negative. So product of negative 4 and negative 9 is 36. Then cross multiply. So negative 16u. This product is negative 9u. Then the sum is negative 25u. Okay, so this sum is same as the term in the middle. So we can write it as a product of u minus 4 and 4u minus 9 equals 0. So set each factor, binomial factor equal to 0. So u equals 4. And from the second factor, u equals 9 over 4, right? All right. We are not looking for the u value. We are looking for what? X value, right? So from here, now x squared u. What's the value of u? The expression for u is x squared. So replace this back to x squared. Now u is equal to x squared, right? So put it back to u. So x squared equals 4. So from here, x equals plus or minus square root of 4. So x equals plus or minus 2. All right, then from here, x squared equals 9 over 4. So x equals plus or minus square root of 9 over 4. So x equals positive or negative 3 over 4. Okay. What is this one? The square root of 9 over square root of 4, right? So 3 over 4. So these are the solutions to this fourth power equation. Okay, plus or minus means this is positive 2 and negative 2. Okay, plus minus means there are 2. One is positive, one is negative. All right, then let's try example 7. Okay, solve 3 times x to the 2/3 power minus 5 times x to the 1/3 power. So don't worry about this because as you see this one, 2/3. Okay, this 2/3 is what? 2 times 1/3, right? That's 2/3. So we can set this one as u. So u equals x to the 1/3. Then this will become u squared, right? U squared. So this will be u squared, right? All right, so rewrite the equation. Then 3 times u squared minus 5 times u minus 2 equals 0. Then u times 3u and 2 times 1. We need a negative sign because the product should be negative 2. Then this product is negative 6u. This product is u, so the sum is negative 5u, which is the same as the term in the middle, right? So this trinomial is the product of u minus 2 and 3u plus 1. So set each factor equal to 0, then u minus 2 is 0, so u equals 2. Okay, we have another one, 3u plus 1 equals 0, and then 3u equals negative 1, so u equals negative 1/3. So from here, let's put back, replace u with what? This one, right? X to the 1/3 power. So since u equals x to the 1/3 power, this equation will become x to the 1/3 power equals 2. All right, then we cube each side, right? Cube each side. So x equals, cube each side. All right, then x equals 8. Okay, from the second part, okay, x to the 1/3 power equals negative 1 over 3. So cube each side, right? Cube each side. Cube it. All right, then x equals negative 1 over 27, right? Negative 1 over 27. So there are two solutions in this example. All right, for this next example is an word problem, application problem. Okay, the story is this. There are two buses, and then the first bus is moving from location A to B, and the speed is unknown. We want to find the speed of the first bus and the second bus. And the total distance from A to B is 120 miles. And then the second bus is 10 miles per hour faster. The speed of the second bus is faster, 10 miles per hour faster than the speed of the first bus. So we can write it as this. So if bus 1 speed is x miles per hour, then the speed of the bus 2 is x plus 10 miles per hour. All right, and the given information is also, and then since the bus 2 is faster, it arrived 1 hour faster than the time that the bus 1 took. So if bus 1 took t hours, then the bus 2 will take t minus 1 hours. So these are all given information. So from this, we want to find the speed of bus 2 and bus 1. So in order to do this one, we need to know the speed in the equation. The speed, how do you say the speed? We usually say the speed in the middle road is 35 miles per hour, right? 35 miles, for example, miles per hour. So that means the 35 miles is the distance, isn't it? Distance. And then the hour is the time. So we can write an equation. So speed, the speed or rate. So let's use S. So the speed is distance over time. Okay, so we have one equation. Then from this equation, we can say multiply each side by t, then the distance is equal to speed times the number of hours, st. And then from here, divide each side by s, then we get what? T equals, divided by s, d over s. So there are three equations. 1, 2, 3 equations. So this rate problem is not easy because since there are three equations, we have to think a lot of different ways to write an equation. All right, so in order to memorize this, we can also say this. Okay, write this, distance, DST, write DST in a triangle, DST like this. And then draw a horizontal bar, fraction bar like this. So this one indicates that the D equals D equals the leftover is ST, right? ST are in the same line, so we can just write it as ST. So the formula for distance is speed times hours. How about the speed? Okay, then speed equals, write down D, and D is separated by the fraction bar, right? So you can write it like this. The speed is equal to distance over time, and the time, you can get the time, so time equals distance is in the numerator, the upper part, and the S is at the bottom. So you can write it as this. Okay, so if you forgot the equation related to the speed, then you can think of these two methods. All right. So, okay, how do you find the time? Because time equals distance over s, right? Time equals distance over s. Time equals distance over the speed, right? Time. So let's use this formula, this equation. So for the bus 1, what is the time it took? So for the bus 1, okay, bus 1, bus 2. So from the bus 1, the time is, the distance 120 miles, and the speed is x miles per hour. So we can write an equation like this. And for the bus 2, okay, the time that bus 2 took is, the distance is 120 miles, then divided by what? The speed. The speed is x plus 10 miles per hour, right? Okay, but as you see this, okay, the time is 1 hour faster than the time that the bus 1 took. So the time for the bus 2 took was this one minus 1, right? Make sense? Okay, I think I made a mistake this one. All right. No, it works. So the speed, the time that bus 2 took is distance over the speed. So 120 divided by the speed, which is x plus 10. Then the time is actually what? 1 hour faster than the time that bus 1 took. So it should be t minus 1, right? So this makes sense. So from here, so we have an equation like this, equation. So in this case, we can replace this t with this value. Okay, so let's now plug it. Let's replace this t. Okay, since t is 120 over x, now replace this t with the t value. Okay, so let's rewrite this equation. 120 over x plus 10 equals 120 over x minus 1. So we have an equation. And this equation has x, and x is the speed of the bus 1. So let's find the speed, x. So how do you find x? Well, remove the denominator by multiplying the equation by what? The LCD, right? LCD. So LCD is x times x plus 1. Okay, what's the LCD? X times x plus 10. So x plus 10. So I'm going to multiply each term by x times x plus 10. So multiply this x times x plus 10. Even this one, x times x plus 10. Okay, then this x plus 10 cancel out. We have 120x equals x cancel out, x plus 10 times 120, and then minus x times x plus 10. All right, then let's simplify this. So 120 x equals 120x plus 1200 minus x squared minus 10x. All right, then minus 120. So move 120x to the other side. Then we have 0 equals 1200 minus x squared minus 10x. So from this one, let's rewrite it so that, let's move everything to the left so that we will have positive x squared term. So move everything to the left, then this will become x squared. This becomes plus 10x, and positive 1200 becomes negative 1200 is equal to 0. Then from here, let's factor this trinomial. 1200 is 3 times 4, right? 3 times 4. So 30 times 40 is 100, 1200, and make negative 30. So this will be negative 30x, and this will be 40x. So the sum is 10x, which is the term in the middle. So this trinomial is the product of x minus 30, x plus 30 equals 0. So as you see this, set each factor equal to 0. Then x equals 30. So the speed of the first bus is 30 miles per hour, right? And the other one, x plus 40 equals 0. That means x equals negative 40. So negative 40 miles per hour. Okay, can a speed be a negative? Okay, negative means you're going backward, right? So remove this one from the solution. So the speed of the first bus is 30 miles per hour. Okay, then let's find the speed of the second bus. All right, since the speed of the second bus is 10 miles per hour faster, so the second bus is 30 plus 10, right? So that is 40 miles per hour. So the second bus, speed of the bus 2, right? The speed of the bus 2 is x plus 10. So 30 plus 10 is 40 miles per hour. Okay, and this one is the speed, right? This is the speed of the first bus. speed of the first bus, bus 1. Okay. Okay, next example is a word problem questions. Okay, let's say if I paint a wall, then let's say it takes, okay, this is a wall that I need to paint. If I take 3 hours to paint a wall, then divide this wall into 3 parts. Then each section is the work done per hour by, it's done by myself, right? So, okay, this piece is 1/3, right? 1/3 of the total job. So 1/3 of the job will be done per hour. So, and then also if there is, if another person takes, let's say, 4 hours, then divide this into 4 pieces. Then each piece is the work done per hour by the second person, right? So if they work together, then let's say, I don't know how many hours it takes. So let's say it takes X hours. Then divide this piece into X pieces. Then each piece indicates that each piece is 1X, so 1/X job will be done per hour. So it doesn't make sense, right? So you can write an equation using this diagram. 1/3 plus 1/4 will be 1/X. So these are the work done per hour. So from this one, we can find X. So using this example, let's try. So here is a small pipe. Small pipe. And then here's the large pipe. Okay, this is a large pipe. And if large pipe takes X hours to empty a tank, then the small pipe takes X plus, okay, this is minutes, so X plus 12. It takes 12 minutes longer than a larger pipe to empty a tank. So it will be X plus 12 minutes. Okay, and then the large pipe takes X minutes. Then if they both work together, then it takes 1.75 minutes. 1.75 minutes. So using the example above, we can separate. We can divide this piece into X pieces. So each piece represents 1/X, right? 1/X of the total job. So 1/X job will be done per minute, right? Minute. Even this one, we separate this into how many pieces? X plus 12 pieces. So this will be 1/X plus 12 pieces. So each piece will be done per minute. So if they work together, it takes how many minutes? 1.75 minutes, right? So each piece is the work done per minute. So 1/1.75 is the amount of each piece. So this many job will be done per minute. Okay, like this. So we can write an equation. So 1/X plus 12 plus 1/X equals 1/1.75. So this is the equation so that we can find X. Okay. So in order to find, this is the equation. So from here, this is 1.75. So from here, let's remove the denominator. So what's the LCD? We can multiply the equation by the LCD, which is 1.75 x times 1 plus 12. Right. So let's multiply each term by this LCD. Okay, so let me write the equation first. So 1/x equals 1/1.75. Then change the color. So multiply each term by 1.75 x times x plus 2. 12, right? 12. Given this one, 1.75 x times x plus 12. X times, okay, 1.75 x times x plus 12. All right, then, x plus 12 cancel out. So we have 1.75x, and x cancel out, so 1.75 x plus 12, and 1.75 cancel out, so x times x plus 12. Okay, so from this, let's simplify. So 1.75x plus 1.75x plus multiply this by 2 by 12. So 1.75 times 12. Why don't we use, you can use a calculator. Is it 12? 21? So that's 21, right? Okay. And then this is x squared plus 12x. So let's keep simplifying this. Okay, so to save time, I solved this one. All right, so as you see this, okay, we rewrite the equation and then simplify each side and then move all the terms to the left. So we have quadratic formula, quadratic equation. So in order to find the x, we used quadratic formula. So quadratic formula is negative b plus or minus square root of b squared minus 4ac over 2a, right? So plug in all these values, then we have 2x values. One is 2 minutes, the other one is negative value. So negative value is not possible. So x is 2. Okay, x means x is the time the large pipe took, right? So since the smaller pipe takes 12 minutes longer than the large pipe takes, so we want to find the time that the smaller pipe takes, which is x plus 12, right? So 2 plus 12 is 14. So smaller pipe takes 14 minutes to empty the tank. All right. And the next question is, this is a mixed question. Okay, a woman is walking down from location A to P, and then from P to B. All right, so the speed is different. So from A to P, the speed is 2 kilometers per hour. Then the distance is, this is a right triangle. So by the Pythagorean theorem, the hypotenuse is what? 2 squared plus 4, right? 2 squared, sorry. A squared plus b squared. So there will be a squared, which is 4, plus b squared, x squared. So that's the distance. All right, and for this distance, from P to B, the speed is 5 kilometers, and then the distance from P to B is 5 minus x, because from the left to the right is 5 kilometers. And then we said from left to P is x kilometers. Right, this is x kilometers, so the rest is 5 minus x kilometers. All right, then also the given information is the walking from location A to P and P to A is 2 and 25 hours. So she took 2 and 25 hours. All right, so that's the total time from A to P and P to B. So from this one, we can separate. We can write an equation for the time that took from A to P and P to A. So the time equation is this one, right? So time equals distance over s. All right, then, okay, from A to P, the time is the distance. The distance is square root of 4 plus x squared. So distance over the speed. And the speed is 2 kilometers per hour. And then from the second region, from P to B, the distance is 5 minus x. And then divided by the speed. And the speed is 5 kilometers. So the total time for these two distances is 2.25. So this is the equation. So from this equation, let's find x. So in this case, why don't we multiply the LCD? Multiply the LCD, which is 10, right? So LCD is 10, so multiply the equation by 10. Okay, so let me write the expression by 10, so multiply this by 10, and then also the second term by 10, and this should be x, and then 10 times 2.25. Then simplify. We can reduce this guy, so 5 square root of 4 minus x squared plus 2 times 5 minus x equals 22.5. Okay, I keep going. This is x. What do I keep writing for x? Okay, then 5 times square root of 4 minus squared plus 10 minus 2x equals 22.5. All right, and then move every term to the other side. So leave only the radical expression one side. Then move others to the other side. So negative 2x becomes 2x, and then minus 10 each side, so there will be 12.5. Right? And then now what? Now we square each side. Okay, square each side. So let me move to the next page. Okay, I'm gonna take a square root. Take a square each side. Then this is 25 times 4 minus x, right? Then the first one squared, so 4x squared. So why don't I write 2x squared? 2x squared plus 2 times the first term and the second term plus the second term squared. So this is 100 minus 25x equals 4x squared minus plus, okay, 2 times 12.5 is 25. So that is 50x plus 12.5 squared is, okay, use a calculator, then it will be 156.25. All right, then move every term to the right. So 4x squared, then move plus 25x, so plus 75x. Okay, and then move 100 to the right, so minus 100, so that will be plus 56.25. Okay, let me check if this is correct. All right, there's a mistake. Okay, let's go back. Okay, the distance from A to P is square root of 4 plus x squared, right? 4 plus x squared. So this one should be 4 plus x squared. 4 plus x squared. So this is 4 plus x squared. Then this will be 4 plus x squared again. Then finally, this will be plus 25x squared, right? So we can remove this. So move 25x squared to the right. Move this minus 4x to the left. Minus 4x squared to the left. Then it will be 21x squared, right? And then move this one to the left, so minus 50x. And then move this one to the left, so that is negative 56.25 equals 0. So from this, we can use a quadratic formula. Use the quadratic formula, right? Then use the quadratic formula, then the x value will be negative 0.8, or x is equal to 3.2, right? So, x has to be a positive number, so the answer is 3.2 kilometers. Okay, so the answer is 3.2 kilometers. All right, this section took a long time because this chapter is related to application part, and application part is not easy, so it took time. All right, then we are done. So please do the homework. Okay.